MinebeaMitsumi introduces a cost-effective miniaturized gauge pressure sensor for breath detection in face shield and mask applications. The MMR920 micro gauge pressure sensor utilizes microelectrical mechanical system piezoresistive technology with an integrated analog front end. It is fully calibrated and temperature compensated with pressure and temperature output through digital I2C or SPI interface. The MMR920 is a highly sensitive sensor, able to detect pressure changes in the range of 1/1000th of an inch of water column. In this video, we demonstrate the effectiveness of the MMR920 in a mask and face shield for respiratory monitoring. One end of a small tube is taped onto the inside of the mask or face shield, while the other end is connected to the MMR920 pressure sensor evaluation kit. The tubing is secured to the exercise bike frame to limit signal noise induced from tubing, movement, and vibration. The first test run is performed using a clear shield where the lower portion is not tightly sealed against the face. The second test run is performed using a cloth face mask marketed for respiratory infection protection with much tighter facial seal. The MMR920 sensor is only able to detect exhalation pressure during the experiment. The absence of a tight seal prevents negative pressure from being generated within the shield during inhalation. The respiratory cycle can still be determined by the distance between positive pressure peaks. The section of the tube near the mask is not taped down and generates noise with movement. The MMR920 is able to detect both inhalation and exhalation inside a face mask. With a better facial seal, it's possible to generate negative pressure during inhalation and positive pressure during exhalation. The respiratory cycle can be determined by the distance between peaks, either from positive to positive or negative to negative. Even with an open-type face shield, the MMR920 is able to detect exhalation events, making it suitable for breath-counting applications. When the test subject remained motionless, a decrease in noise was observed. Therefore, noise generated from tubing movement would be significantly reduced by integrating the MMR920 into the face covering. Using the MMR920 in a face covering with a tight seal, respiratory signals are more defined, and the sensor is able to detect when a breath is taken and expelled. The high sensitivity of this sensor makes it suitable for breath counting applications without airflow restriction, such as athletic wearables or sleep monitoring devices. To utilize the MMR920 in these types of wearables, a cap is needed to cover the nose and partially cover the mouth in order for pressure to build up during exhaling. Its ultra-small footprint makes it easy to integrate into wearable devices along with necessary electronics. For face covering applications that have a tight seal, the MMR920 allows manufacturers to detect breathing rate as well as possible correlation to relative tidal volume. Sensitivity and fast response time make the MMR920 ideal for applications where breathing event detection is required for optimization, such as CPAP machines, oxygen concentrators, and smart inhalers. For more information about MinebeaMitsumi, please visit us at www.nmbtc.com.